Hey everyone, and welcome to This Explainer. I'm Architect 1, and I'm hanging out today with Architect 2 to unpack one of the most game-changing concepts from Google's site reliability engineering model.
So great to be here. If you're a cloud architect, a platform engineer, or tech leader, you absolutely know the pain of trying to scale your operations while just drowning in manual work. Trying to keep systems reliable while you're constantly shipping new features, it's a massive challenge. So today, we're breaking down exactly how to conquer it by relentlessly eliminating toil.
All right, so here's our game plan for today's explainer. We're going to hit scaling and operational complexity, then defining toil in operations, move right into the hidden dangers, talk about the SRE automation solution, and finish up with measuring and limiting toil. Let's dive right in. Architect 2, Section 1, Scaling and Operational Complexity. So as organizations scale up, operational complexity inherently increases, right? There is just no avoiding that reality. But here's the thing. Relying on manual effort creates severe operational inefficiencies. It basically acts as a hard ceiling, literally a boulder crushing your organization's ability to scale. You simply cannot scale your human capital at the exact same rate as your cloud infrastructure. It just doesn't work.
Exactly. You hit the nail on the head. The only way you break through that ceiling is by unlocking scalable operations and true reliability through automation. That's your rocket fuel. If your whole strategy relies on human intervention just to keep the lights on, well, the entire model is going to break down the second your traffic spikes.
Moving right along to Section 2, Defining Toil in Operations. Now, people very often confuse toil with just stuff I don't really want to do. Like writing documentation, filing expense reports, or sitting through another long architecture meeting. But that's not it at all.
Right. Google's criteria for toil is actually highly specific. It is operational work that is manual, repetitive, and automatable. It's tactical, meaning it's interrupt-driven and entirely reactive. And honestly, the most important part, it lacks enduring value. If you finish a task and your system is in the exact same state it was yesterday, just running but not actually improved in any meaningful way, that, my friends, is the definition of toil.
And we've all lived through these enterprise examples, haven't we? Manual deployments, repeated server provisioning, applying the exact same hotfix to the exact same alerts week after week.
Oh, for sure. The endless grind of ticket-driven operations is absolutely the worst offender here. It is so exhausting when highly skilled engineers are essentially reduced to acting as a human API. You know the feeling? You're just sitting there copying and pasting commands from Jira tickets into your infrastructure all day long. It's a massive, massive drain on your operational resources.
And here is the brutal opportunity cost of all that. Toil consumes precious engineering time without actually improving the system itself. Every single hour spent acting as that human API is an hour you literally never get back.
Totally. If your senior cloud architects are bogged down manually provisioning environments, well, they aren't engaging in enduring value engineering. They aren't optimizing the architecture, they're not improving your security posture, and they definitely are not enhancing system resilience.
Which brings us to Section 3, the hidden dangers. High levels of toil create some massive business impacts. Reduced productivity leads directly to slower innovation. And the hard truth is, your competitors who have actually automated their delivery pipelines, they will consistently outpace you. No question.
Absolutely. And we really need to talk about the human impact here too, which is burnout. Engineers want to engineer, right? They don't want to act as robots. When burnout hits, you don't just lose top talent. You get operational inconsistency. Manual operations are inherently prone to human error. A tired engineer running a manual deployment script on a 2 a.m. PagerDuty call, they are going to make mistakes. And that leads directly to downtime.
Now, here is a terrifying mathematical reality for engineering leaders. As organizations grow, toil actually grows faster than headcount.
Yeah, think about it. If your server fleet doubles, your operational overhead doesn't just double, the complexity multiplies it. You simply cannot hire your way out of scalability limits. If your only strategy for handling more scale is just adding more operations engineers to close more tickets, your entire cost model will eventually collapse.
Let's talk solutions. Section 4, the SRE automation solution. To actually fix this, we have to look at modern platform engineering. The objective here is to utilize the SRE toolkit to eliminate repetitive work entirely. We're talking about building self-service platforms so developers can provision resources safely without waiting on an IT ticket. We utilize infrastructure as code and GitOps, where a simple pull request automatically syncs the cluster state. It's brilliant.
It is.
But I do want to throw out a warning about a very common automation mistake we see all the time. Automating a broken manual process just gives you a broken automated process. Seriously, you have to achieve operational standardization first. We aren't just scripting away problems, we are embedding our operational knowledge directly into code so we don't have to rely on tribal knowledge anymore.
All right, Section 5, Measuring and Limiting Toil. Now, you've probably heard the saying, you cannot manage what you don't measure. Mature SRE organizations don't just complain about toil at the water cooler, they relentlessly track it.
Exactly. They are looking at the percentage of time their engineers spend on operational grunt work versus strategic project work. They track manual deployment frequency, which, by the way, absolutely needs to trend toward zero. And they monitor ticket volume for repetitive requests. That volume is your biggest signal for exactly what needs to be built into your self-service platform next.
Google's SRE book actually lays out a hard truth for the industry here, and it's a strict 50% cap. Engineering time spent on toil should be limited to approximately 50%, at an absolute maximum.
Yeah. If an SRE team is spending more than half their time just keeping the lights on, well, they're essentially just a traditional ops team at that point, and the reliability of their systems is inevitably going to degrade. That remaining 50% of their time must be fiercely protected for coding, automation, and enduring value improvements.
The ultimate takeaway of our conversation today really comes down to this core SRE philosophy. Every repetitive task is an opportunity for automation.
That's it right there. True reliability and operational scalability are never, ever achieved by throwing more manual effort at a problem. The most scalable enterprise organizations are the ones that ruthlessly identify and engineer toil right out of their daily workflows.
Which leaves us with a final challenge for you and your engineering teams. Building sustainable operations requires a proactive mindset. So look at your own enterprise environments. Look at those ticket queues. Look at your runbooks. What repetitive task will your team automate tomorrow? Identify the toil, write the code, and reclaim your engineering time. Thanks so much for joining us on this explainer. Get out there and start applying these principles to your cloud architecture today.